exactly. So before starting answering the assignment, please watch the video and do the steps I am doing with me together. So maybe you open this video on your phone and use your computer to work on your assignment. So just to mention, you have step-by-step information about this assignment inside the weekly assignment 2 under the link in number 1. And also you have the data set, so download the data set to your desktop computer and start step by step working with me in this assignment. So let me close this. Okay, so open the data, so direct mail data, and after opening the data you should be able to see the data. Okay, to give you some background about this case scenario, so here we go. We have an antique dealer who recently opened a shop. The store is open to the public on Tuesday through Sunday from 10 a.m. to 6 p.m. Direct mail, it's very known, easy method to market your business, especially when you have a small business. Let's say here in Bowling Green, you open the small business and you want people to know about you. So you go ahead and create some flyer and you print those flyers and you try to use maybe the US post office to drop those flyers to customers. So this is one method, okay? Now, something to pay attention to, that this business is sending those flyers on Wednesday, every Wednesday, okay? Now, what is the purpose of this case scenario? We are trying to find if there is a relationship between the amount of sales that business is making with the amount of payment he is paying for this unsolicited flyer. Okay, if there is a relationship, so he will keep doing it, because actually it cost him money to put to print the flyers first, it's colored print, and then to put them in an envelope and put the postage on them. So there is a cost. So somehow this business, let's say, hired you as a business analyst to tell the owner if really his method of marketing is sufficient or if it's not. Okay, so the data that we have, the direct jump data, has information about the sales, how much they made every week, and about the direct mail that they spend on weekly basis. So here's our data. Our data consists of 19 week. Okay, we have week 1 to week 19, and for each week the amount of sales that business made. And it was noted in the handout that the sales are presented by by thousands, which means where you see 12 at the first row here, it means $12,123 they made. Okay, the second week they made $21,209. Now, what else you have to pay attention to, that the color row of the direct mail, this is by dollar, so $98 they made, they spent for the first week, flyers, print, postages, and sent by the US Post. So this is our data. As usual, when we look at data like this, we try to understand the data, and like every case scenario we have visited with Jump now, our starting point always is to look at those attributes, and we have two of them. The sales attribute, which is, as you can see here, it's a continuous variable, and the direct mail as well, it is a continuous variable, and the week is continuous variable. Our goal, to see if there is a relationship between those two attributes. But as we said, we have to understand the summary statistics of this data before even trying to find a relationship. So let us click outside this column. So always remember not to start any analysis. Just make sure you are not selecting one element and you're running the analysis on that element, okay, on one row. So first of all, we're gonna look as usual on the distribution, and the distribution is very nice. It gives you all the statistical output, the mean, the standard deviation, the variance, the mode, the median of your data, the quartiles. So that's good information. We're gonna take those two variables. I ignore the week because there is no information in the week really. It's just the number of the week. I'm gonna bring those, both of them, as a Y column, and I'm gonna say, okay, draw for me the distribution of my data. Here we go. So if you don't see them in this look, you can flip it by clicking on the stack. First of all, let us look at those two individual variables, not as a relationship between them, just as the summary of statistic. The cells, it has a mean of 42, and we said this is by 1,000, we have to multiply 42,000 on average this business is making. Okay, what else? The standard deviation, which means how much far away from the mean is the variance or the variation in the data, about 18,000, which means like this business one day maybe will make 42,000, maybe another day will make about maybe 25,000. So it's a big difference somehow. However, if you look at the distribution, it's a normal distribution, it's not too skewed. What else? So at least now we know what's going on with our data. Now look at the direct mail, how much they spend during this period. On average, they spend about $420. Okay, and the standard deviation, which means how much more or less they spend on weekly basis, it was 207. It's almost like you are saying subtract 200 from the 420, so almost 221 day, the lowest time they spent, and maybe on the other hand, or the variation from the standard is 220 to be more correct, and maybe plus, so would be 620 with one standard deviation. Now if you want all of it, you multiply standard deviation by 3, and then you add and subtract from the mean. In this way you will get 90%, 99%. As you know, 3 standard deviation from the mean represent 99% of your normal distributed data. In this way you know exactly how much the lowest amount you paid and the highest amount you paid. Okay, so far nothing bad about this data, just you can see there are no outliers. Maybe here one outlier, very small. It's not so far actually from the whisker. It's the mean, and the median. See, they are having almost the same place. So remember, the mean is this diamond shaped, and the line, the vertical line, represent the median. So, and you can see them from here. 42,000 is the mean. Again, the median 42,004. Very small difference. Exactly the same here. Here is the mean, $420, and the median 430. So data is quite, no problem with what I see in this data. Now, so let us save this distribution. As we learned, you click on the distribution, save to table data. I'm gonna keep it, yes, that's it, and we're gonna have it over here. So now I'm gonna close this window, which just our starting in this data. The second part of this case scenario, because we have the timestamp in our data, it's always wise to generate what is called the time series plot. That's typical always to have in any data you have time. You would like to look at the cells, for example, over time. What happened to all those cells since we started our business to the last week we collected the data? Okay, so hopefully you would like to see that you are making more money and you are not just the opposite, you are losing money. So let us do that. Again, I'm gonna click outside on those triangles, and from here I'm gonna try to use a graph builder. Okay, and again you can use other type of functions, plots in your jump output, but this is the easiest way to plot information. So I'm gonna drag. Again, what I'm gonna try to do, I want to see my cells over time. So the Y will be my cells, and over time the X will be the week that we have data of. So this is our week, and all I'm saying, show me what's going on in my cells over the week. Automatically JMP will create a scatter plot, and we talked about this in the class. Scatter plot is not only is nothing but the points are of your data are presented on your chart. And there is this smooth line. We're gonna remove it just to show you the direction of your data. We don't need it. And because we are creating a time series plot, you will have to consider not a scatter plot type of data, but rather a line relationship. So I'm gonna click on the symbol that shows the line, and I'm gonna click on it, so it will give me a better look on the connection between the points. So let's say the first week we made about 12,000 in our cells. In the week 10 we made about 78,000. Big growth, okay, compared to what we started with. On the week 16 we made 74,000. So as you can see, as a summary of running this plot, that we have a lot of infatuation in our data is going up and down. However, the major trend that is going up, okay, you can see it's going, our sales going up. Okay, so somehow this is a positive, so far a positive look to the sales of this business. If you want to save it, save the script to table data and say yes, it picked very nice, even the title, sales versus week, and that's it. Gonna close it. So technically now we have those two scripts that you can regenerate in case you want to look at them one more time. Now that we know that we are doing better over the weeks, we want to know if really the direct mail affecting our sales. If it's not, we might stop completely paying for those flyers, and maybe we are becoming famous in Bowling Green, and we don't need to spend more on those flyers to send them and to pay for postages and to mail them. So to find a relationship between two variables, you might start with the correlation, but since we learned about the correlation, now let us move to a more sophisticated model, which is the simple linear regression models. So we want to create a model, and the purpose of creating a linear regression model would be that because you can do forecasting, like you can know what the value gonna be, how much sales you're gonna make next the week of 20 or the week of 25 based on the information of the linear regression. Okay, that's why you are going to try to create a regression model. So first of all, how you create a linear regression model, one way or other, one of them which is the fit yx. Again, what kind of relationship we are creating? We are creating a relationship between the cells and the direct mail. We want to know if direct mail has an effect on the cells. So the cells is our y, our response, and the one we want to see if it has value, a factor or affecting our cells, our x, is a direct mail. And we gonna remember always to look at the type of analysis. It's continuous type, continuous, you're gonna have a bivariate relationship, and we're gonna say okay. And as you noticed that automatically is gonna put the dot, but it's not creating a linear model for you. Jump, you will have to add it to the model. So first of all, let us first fit a line into this model, and the way you do this, you click on the rectangle and then you are looking at fit line. So not only is gonna create a line for you, but also is gonna produce the linear regression equation that you want to look at. Okay, so this model based on the cells and the direct mail is equivalent to the following. So y, which is the cells, our y, equal 33.3 plus 0.0224 multiplying by direct mail. So this is our y. 33 is a point here where the direct mail equals 0. So what is called the intercept. So this is the intercept. This value here is the intercept. Okay, this is the intercept. When direct mail equals 0, so this value disappears, cells. So that means based on this model is telling you your business. So remember, you're the analyst, you're telling the CEO or the owner of this company, your business is making 33,000. Remember the numbers in cells, they are, you have to multiply them by thousands. You are making 33,000 without direct mail. Okay, that's what this equation says. So let us first, okay, this is what the linear regression model created by this data. However, we are not sure if there is a linear regression between the cells and direct mail. There are some measurements we have to look at to decide if this is a correct model or not. So to explore the significance of this fitted model, we can select the fit mean as well to see how far away is this model from the mean. And the mean, remember, it's like random sampling that we do nothing, just we calculated the mean. Okay, so I'm added from rectangle, again I added the fit mean, and as you can see is adding those two rectangles that we can do more with them. Okay, so now we have extra report, extra control on our data. So looking at this, we can see that really our model is not so far, this line is not so far from the mean. Now, to even get a better understanding how confident you will be with this model, we can do an extra stuff. We can create what is called the confidence curve fit of our model. So how we can do that? Let's click on the linear fit and we are gonna select the confidence curve fit. And what it does is gonna create what is called the plot confidence bands. which is around the linear regression, how much errors or how much space you have, that 95% up and down. So these lines created over here are called the linear fit confidence bands. And as you can see, the mean is inside those confidence bands, and I really don't see that much difference that the linear regression model can make if compared to the mean. Okay, now something else to look at after you are trying to justify if this is a correct linear model or not. You're gonna try to look at the summary statistics generated by the linear model, the one over here. So first of all, you look at the analysis of variance, and all it says, you wanna see if this model, the red line, generated with the following equation, is a significant model. What I mean is a significant model. Is this model can explain the variation in those points? You see how the real points are far away from the model? So all I'm saying is this model is better than just taking the mean of the values, the mean of all the points in my data. Is it much better? And how can I get that? Is by looking at what is called the F ratio. Explaining the F ratio. So every time you generate a model like this red line, that model will have a total sum of error, and the total sum of error is divided into two components. So pay attention to me. The total sum, which is the value here, the C total, the total sum of errors of any model you create from data, is divided into two components. Errors are generated by the model you created, but the model can explain those variation, okay, from the name, the variance. So your model will have a total sum squared error, which equal to the sum of the total sum squared from the model and the total sum squared from the error that the model cannot explain. Okay, so if the value of the sum squared error the model generates is much bigger than the one of the error being generated, we will have a good model. However, this is not the case here. So let's back up a little bit. The total sum squared error of any model you generate now in future is equal to the sum squared model error generated from the model plus the sum squared error that the model cannot explain. Okay? Again, what's the meaning of explain and not explain? The variation in this data, the model can explain it with this value over here, mean square, and the variation that cannot be explained and considered as an error is this value over here. Okay, now the F ratio is what? The F ratio equal to the division of the total division of the model sum square over the total sum square, or in other words, equal to the sum square of the model over sum square of the model plus the error. So now you can see why it's important to have a very small error. And as a result here, as you can see, the value of this ratio is not what we expected. It should be a p-value of less than 0.05, if you remember. Okay, otherwise we can say this model we created, this red line, is not a good fit for our data. So first of all, always you look at this probability of the F ratio. If it's equal or less than 0.05, you say you have a good model. In our case here, we do not have a good model. This is one. Number two, what you look at as well is what is called the R square. R square is nothing but a relationship in the simple model, like in our case here, cells and direct mail. It's a simple model, just one x, and like we have only one predictor for our response value. The R square, nothing but is the square of correlation between those two variables, the cells and direct mail. So if you run the correlation between cells and direct mail, you will get the R, and that value, just to square it, will give you the R square. Now if you are using multiple linear regression, then that's not completely correct. You will have not, because it's not between two variables, you have a relationship between the response and multiple x's. So in that case you focus more on the adjusted square. But in the time being, that's out of scope of this class. In the time being, the R square here, and as you remember, what is the correlation? The correlation is a value between -1 and 1, and the higher than the 0 is the better in both directions. We are squaring the R. That means now our value is only between 0 and 1. The higher the value of R, the 0.5, which means is better than this mean average, the green line we have here. So having said that, this value here, 0.063, is so small. Almost you are saying that your model is only capable of explaining 6.3% of the variation of the model. You would expect something like 0.8 here, and you would say, oh, my model capable of explaining 80% of the variation in the data. That's a good model and I will use it. So according to our finding here, we reject this model. This is not a good model. So I'm gonna save, but we are not gonna use this model because this data is not represented by this model. Okay, I'm gonna close this. Now in your handouts, you will notice in your page, let's see which page, maybe page number 3, that I'm saying the following. Remember when we started, so let me bring this one here. Remember when we started our case, I reminded you that the direct mailing are sent out every Wednesday in this business. Okay, that's mean, and especially let's say you are in Bowling Green, and if you are using the US Post Office, highly likely those flyers will not arrive at those residents till the next week. So which means let's question our data. So if you read in page 3, you will see the following. Like, technically, that the time sequencing of the relationship between the cells and direct mail is not correct in the data we have here, because always there is a delay between the time you send and your flyer and the time people receiving it and seeing it. Okay, so what we are gonna say here, we have what is called lag in delivery time. So we are gonna change the data we have here by lagging the information of the direct post for at least 1 week, and we'll see what's gonna happen to our data. If the model that can explain the relationship between those two would be better. So again, all I'm saying here, that the data we looked at is really not explaining correctly our data. So what we are going to do now based on what we decided or what we discovered, that we need really to lag this information in this column. So we're gonna create a new column. Just a click with your right mouse click, a new column, and in this one let's name it lag direct mail lagged. Okay, and you will see in your assignment you're gonna do similar to this but for more than 1 week. Okay, so we're gonna say, yeah, this is the name. Now we're gonna create a formula, very easy formula. All it does, it moves the 98 to the second week, 212 to the third week, etc. So is lagging the information for 1 week. Right click on the same column, click on what is called formula, and from the formula now click on the row, and we have something called lag. And as you can see, you have plenty of functions you can use in JMP available for you. So I'm gonna say I want to create this new column with the following value. The value of direct mail lagged is equal to the current direct mail plus 1. Just add the second number to it, like shift the lag for 1 unit. You can shift for 2, 3, etc. And I'm gonna say apply, and as you can see, it did the shift. It shifted the values to the second row, and that's it. Simple as that. Now, based on this finding that we believe that maybe the first linear regression model we created wasn't adequate because of this lagging in the system. So let us try to create now the relationship between the direct mail lag and the cells. Just repeating. Analyze, fit y by x. Our y is now the cell, and now the changes is the axis is no longer in the old one but the one was lagged, and say okay. So we created a bivariate fit, and as we did before, we're gonna add the fit line, the regression model, and accordingly, as you can see here, somehow, as you can see, the data are close to each other than before. They were so scattered before. And if you want to first compare with the mean, with the fit mean, so let us create the fit mean. You can see it's better. How much better? We have to measure it. Just be patient. So after doing that, let us go down here. First of all, a very significant big difference we have here now, that the p-value of the f ratio, which is nothing but dividing the model squared error, which is this value here, okay, which is about 2000 now 159, over the sum of 2159 plus 187. So as you can see now, the ratio is much smaller, and less than 0.05, 0.0037. So what you're saying here, my model's new linear fit regression model is significant based on this p-value, which means is capable of explaining the variations in the model. Okay, something else we said we're gonna look at is the R square. The R square is much better than before. So this model has a value, this is how you explain it, 41.8% value that, okay, let's switch it a little bit. This model has R squared equals 0.418, and always remember that the R square has a value between 0 and 1. is not bigger than 0.5, but since the model is significant, I will accept it as a good. It's somehow it's not the best, but it's good enough. And what else? This model is capable of explaining, this is how you interpret the R square. This model is capable of explaining 41.8% of the variation in the model. So every model you create in the world, it's a sampled model from the population, and the sample model we have here has a R square that can explain about 41% or 42% of the variation in this model. Okay, not bad, not bad at all in the time being. Okay, and even if you looked at the estimate, the parameter estimates, you can see the t-test, you can see the value for both of them. The p-value is significant. Both of them are bigger than 0.05. Okay, so what else we are gonna do here? We can create also the bands. Remember what we did previously? So I'm gonna click on the linear fit, and I'm gonna look at the confidence curve fit, just to look at the band in the data. And as you can see now, there is a difference. See how those values are outside the band? So there is a difference between the model we brought and if we just consider the mean average of the points. Okay, so far we are considering that this is a good model which has 42% of its variabilities can be explained by this model. Okay, now what else? The root mean squared error in this model is equal to 13.702, which means multiplied by 1000. This is what we are talking about, that it's about about 13,702 dollars is the unexplained variation in the weekly sales. Okay, that's how you interpret it. So based on this model, we can explain good enough information from it. However, the value of the root mean square error that we are not able to explain by this model is equivalent to 13,000 plus 13,702. So it's based on now your judgment. Do you think this model is sufficient enough, or maybe we have to lag it for 2 weeks and get a better model? Okay, now what else we can do with this formula is forecasting. We can predict how much sales we can make next week based on a value that we're gonna pay for direct mail. That's awesome. Okay, so maybe you see if there is a really benefit of increasing the number of flyers you're gonna spend in town, really gonna make more money. That could be very beneficial. So we're gonna investigate this, and we're gonna look at those values together. So to be able to do that, to be able to do the forecasting, we are gonna create what is called the prediction interval of sales. And how can you do that? Okay, so based on the value under the linear fit, so let's click linear fit, confidence curve individual, which will create with 95% 2 confidence values for us. Okay, beside that, okay, so that's good, but let us save those values. We can get those values from the model. So if you click on the fit mean, linear fit, you can now save those values. You can save the predicted values on the same table. Can you see? So you have now the predicted sales based on those intervals that we created is going to be added to your data. So all it says, look at this value. The actual value of the sales is 21,000. Based on the model we created, the predicted sales based on that model is equivalent to 27,000. Now from our model, we are gonna save not only the predicted sales, but also we're gonna save what is called the lower 95% individual cells and upper 95. So will be like upper and lower value of this predicted cells. So how can we do that? While your model is open, we are going to select from analyze fit model. Okay, and from the fit model we are going to select the direct first of all, the Y is our cells and the direct mel lagged is our effect. So we want to construct model effect for the linear regression model we created with 95% upper and lower value. So let us say run. You're gonna see those outputs that we're gonna use them to see, to add them to our data. And the way you do this, so we're not gonna investigate the values and the chart. All we need from this output is to create to click on the response cells, save column, and then from there you have to look at the individual confidence interval. That's it. And what's gonna do this, now we don't need this window. All the help from this window is to give us those 95% upper and lower value. As you can see, they've been added to your data and also it's been added as columns. So let's back up one more time. We were able to create a predicted cells, then we were able to create the upper and lower 95% of the individual cells. Okay, that's really important. So now what we're gonna do, imagine the following. You want to forecast how much sales you're gonna make in week 20. So let us click row 20 and look what happened. Automatically the model is telling you if the model that we used is the correct model. Somehow it picked the pattern in this information and it told us, based on the historical information here, if you pay 376, which we already know the value because this is a lagged week, remember? So all it did, it picked the value that was lagged last week and put it over here, and it gave me how much sales, predicted sales gonna be. So if I pay this amount, I'm gonna get almost $42,000 next week. Now those upper and lower are important because it's telling you you're gonna make 42,000, or you might get upper level to $71,000. So this is like a margin, the highest value that you can get and the lowest value you can get, and the mean is about 42,000. Now let me bring the assignment that you have to do on your own. So after doing all this and saving the data, would be great. Your job is to do the following. Read the statistical inside of this data, it's important. However, what you have to submit by April 9 is the following. You are going to determine whether a 2 period lag of direct mail, so assuming we are saying that people did not receive the US Post flyer that I sent in immediately next week, but it took almost 2 weeks to receive it. So we're gonna lag the information for 2 weeks. You're gonna repeat creating a fit linear regression model for the sales and direct mail with lag 2, and you're gonna compare the p-value, r-square, the RMSE, since I explained it here in the video, so do that, and the predicted value and the predicted intervals for the data. And then tell me which of the two models, the one we created with 1 week lag or the one you created now on your own with 2 weeks lag, which one of those is better? And we have metrics, remember the p-value there and r-square, we have values there to tell us if which one of those two is the best. And after that, why would it be unwise to consider higher order lags, let's say 10 weeks lag for direct mail? That question will be answered based on your own. Is not related to JMP. You as individual, you were asked by the owner of this company and he told you maybe it needed 10 weeks for the direct mail to hit those houses. How you convince him that this is unwise, and why do you think this is unwise? That's it by now, and hopefully this video will help you answer the assignment of this week.